Good day and welcome to our class on real analysis. In today's class, we'll be proving some theorems on the Cauchy sequence. The first theorem we'll be proving, prove that every Cauchy sequence is bounded. Prove that every Cauchy sequence is bounded. This implies showing that if a sequence is Cauchy, then it is bounded. So we want to go ahead and prove this. Let A sub n be a Cauchy sequence. Let A sub n be a Cauchy sequence. We want to show that A sub n is bounded. That means A sub n, we want to show that it has a lower bound and an upper bound. But we'll recall by definition of Cauchy, sequence, a sequence is Cauchy if for all epsilon greater than 0, there exists a P belonging to the set of natural numbers such that A sub m minus A sub n is less than epsilon for all m and n greater than or equals to P. Let epsilon be equals to 1 and our m to be equals to P. It means that the absolute value of A sub m minus A sub n is less than 1. So this brings us to A sub P minus A sub n is less than 1. And this is minus 1 into A sub n minus A sub P will be less than 1. And so we have absolute value of A sub n minus A sub P to be less than 1. By equivalence, we have minus 1 to be less than A sub n minus A sub P, and that is less than 1. If we had A sub P all through, we have minus 1 plus A sub P to be less than A sub n to be less than A sub P plus 1. A sub P minus 1 is less than or equal to A sub n less than or equal to A sub P plus 1. And this will be for all n greater than P. For all n greater than P. What does this tell us? It tells us that every term of the sequence A sub n will be bigger than A sub P minus 1, but less than A sub P plus 1. Let's use strictly less than. So that can be completely true. Every term of A sub n will be bigger than A sub P minus 1, and it will be less than A sub P plus 1. And so that implies that what? A sub P plus 1 is an upper bound, and A sub P minus 1 is a lower bound. A sub p plus 1 is an upper bound, and a sub p minus 1 a lower bound. But these two may not be sufficient to bound a sub n. That means a sub p minus 1 and a sub p plus 1 may not be completely sufficient to bound a sub n. Therefore, let us take our lower bound L to be the minimum of all of these, A1, A2, A3, down to A sub p plus 1, and it continues like that. And our upper bound U will now be the maximum of A1, A2, A3, down to A sub p plus 1, and it continues like that. So our L is less than or equal to A sub n, and U is greater than or equals to A sub n. So L is less than or equal to A sub n, and A sub n is less than or equal to U. Therefore, L less than or equal to A sub n less than or equal to U. And that for all n greater than or equals to p. Therefore, the sequence A sub n is bounded. Therefore, the sequence A sub n is bounded. And that takes us to, if a sequence is Cauchy, then it is bounded. We can then imply that since A sub n is Cauchy, then every Cauchy sequence is bounded. Every Cauchy sequence is bounded. And that is the proof. If you have gained anything from this proof, which I'm sure you must have done, give it a thumbs up and share with your friends and colleagues. Thank you. I see you in the next video.